Welcome and thank you for joining. In this lesson, we'll explore the one-sided limits. So the one-sided limits describe the trend in the y values or the estimated y values of a function as x approaches a specific value from the left or the right side of it. So by one-sided limit, we mean either one of the following limits. So the limit of f of x when x approaches a specific value from the left side of it, so a minus, or the limit of f of x as x approaches a specific value from the right side of it, so a plus. So let's take a look at some examples where we'll discuss the one-sided limits. So below is the graph of f of x equals 1 over x minus 2. As you can see here, there is a vertical asymptote at x equals 2, and that would be at x equals the restricted value of the function. So there is x equals 2, the vertical asymptote. And the horizontal asymptote is obviously right here at y equals 0. So what we are trying to do here is determine the value of the function at 2. So that means we have to find 1 over 2 minus 2, the value by substituting x by 2, that's 1 over 0, which means that the function is undefined at x equals 2. So next thing that we want to do is find the limit of the function at 2, or estimate the value of y at 2, or describe the trend of the y values at 2. So in order to do this, we approach the value of 2 from the left and from the right-hand side, and that is because at 2, we cannot evaluate the function. So we say that the limit as x approaches 2 from the left-hand side. So here is 2. The left-hand side of 2 will be on this side. So that's 2 minus. And as we approach 2 from the left-hand side, you see that the closer we get to number 2 on the left side of it, the further down the y values go, or we're going to say that the y values will approach negative infinity. When x approaches 2 from the right-hand side of it, we see that the values of y will approach positive infinity because they increase faster and faster the closer we get to x equals 2 on the right side of it, so positive infinity. Now, as you can see, the left-hand limit is negative infinity, the right-hand limit is positive infinity, which means that the left and the right-hand side limits are not equal. In this case, we say that if left and right-hand side limits are not equal, the limit at the point does not exist. The reason why is because remember that the definition of limit is the tendency in the y values at a specific point. So we need to have a common trend to say, okay, so at x equals 2, the function is undefined, but the values of y are about this number. So the limit or the function is not approaching a specific x value, but it is approaching actually two very opposite y values that are far apart from each other. So we don't have a definite number that we can say the limit equals, and that's why we say that when left and right hand limit are not equal, that means the limit at that point doesn't exist. So now we're going to take a look at another function. So what you see here is the graph of 1 over x minus 1. So this would be the first part of the equation. This is a piecewise function. And the next piece is this blue graph in here. So that is the function y equals 4. And the last piece in here is this green function, which is y equals x minus 8 squared. So this entire function obviously has a name, so we're going to call this the function f of x equals all three pieces combined. Now notice how the first piece of a function, which is a rational, exists in the domain between -1 and 3, where -1 is included and 3 isn't. So what you see in here is this red graph that will start at x equals -1, that's x equals -1. -1 is a point included on the graph of this function, and it will end at x equals 3. So this is x equals 3, and x equals 3 is not included on the graph of this function, so we'll indicate this with this empty circle. So I'm going to draw the vertical asymptote in here as well, which is at x equals 1. And we'll move on to the next piece here. That's y equals 4. Y equals 4 is a constant function, so that means a horizontal line. It starts at 3, ends at 6. Both 3 and 6 are included. So to indicate this, we are going to make the ends of the graph, or indicate them with a fill dot. And the last piece is the parabola x minus 2 squared, so this green graph, which will start at 6 and end at 10. And 6 and 10 are not included on the graph, so I'm going to draw the empty circles in here for this graph. So what we're trying to do in here is evaluate the limits of the function at the indicated point. So as we can see here, we have limit when we approach one from the left, one from the right, and then we have to make a judgment whether the limit at that point exists or not. So if we approach number 1, which is right here, from the right-hand side, this is, well, from the left-hand side first, so 1 minus, we notice that as we get closer to 1 from the left-hand side, the values of y are getting closer to negative infinity. So we'll say that the value is of the limit of this one-sided limit is negative infinity. When we approach number 1 from the right-hand side of it, we notice that the closer we get to 1 from the right side of it, the higher the graph goes, which means that the y values are approaching positive infinity. As you notice here, the left and the right hand limits are two different numbers, which means that the limit at 1 doesn't exist. So we'll say that is undefined. Next, we're looking at x equals 3, and we are trying to find the limit when we approach 3 from the left, 3 from the right, and then find the value of the limit at 3 if it exists. So here is number 3. When we approach number 3 from the left-hand side, the closer we get to number 3 on the left-hand side of it, as you see, we hit the red graph on the left-hand side, okay? So the closer we get to x equals 3, the closer the y values get to y equals 1 over 2. So we are going to say that the limit would be equal to 1 over 2. When we approach 3 from the right-hand side of it, so remember that when we approach from the right-hand side, it means that we're not getting exactly at the number itself. So when we approach from the right-hand side, we are simply getting close to the number. And that's what I want us to understand when it comes to finding the limit, because we had a small little discussion in class thinking, okay, so why can't the limit be this number? Because it's on the graph of the function. Why can't it be this number up here? Now, the reason, or the main reason why, is because the problem with it, I don't know what happened to my iPad. I hope it doesn't last very long. Let me change the page. Okay, perfect. So when we approach, oh gosh, I did it again. So as we approach 3 from the left-hand side, we're not getting exactly at 3, so we want an estimated value of y, so, or the trend in the y values as we get to 3. That's what limit is about. And that's why we refer to the red graph when we find the limit on the left side of it. Because on the left side of 3, we only have the red graph, or the rational function. Now, on the right side of number 3 from the right, as we get closer to number 3, we have to hit, or we have to go all the way up to the blue graph, because on the right side of 3, it is the blue graph actually that exists. It's the domain of the constant function here. And we'll say that the limit when x approaches 3 from the right-hand side of it would be equal to, let's take a look, it looks like a positive 4. So we're going to say that the left and right hand limits are not the same, which means that the limit at 3 does not exist. Now, the last limit we're trying to find in here is the limit at 6. So we're looking at 6 from the left and the right, and then we'll make a decision for the limit at 6. So here's number 6. So we're going to approach 6 from the left-hand side and from the right-hand side. Now remember, we're not letting x be exactly 6. We're just estimating the values of y close to 6. So if you approach from the left-hand side, it seems that the values of the function are becoming equal to 4. So we are touching the blue graph in here. So we'll say that the value of the function will be 4. When we approach 6 from the right-hand side, so this time the values of the function are on the green graph. So the values of a function are approaching 4, and I'm going to write here from the right we have 4 as well. So as you can see here, limit on the left and the right are equal, which will make the limit at 6 exist and equal to 4. So that limit will exist, which means that we have a predictable value of y for this function at x equals 6. So we're going to take a look at more examples in the next video. I hope this made sense, and see you next time. Bye for now.